So in this video we are going to see how to solve a live variable analysis problem. So you would need these 4 rules in order to solve the problem. Just go through it once and I will explain how to apply these rules while I'm solving the problem. Okay. So the problem given here is, so you'll be given a flow graph and each of these numbered statements represent a block. Okay. And there's a loop from block 5 to block 2. Okay. Moving on, we will calculate the gen and kill sets. It is always recommended to go from back to the front, the last node to the front node, so that will help us in the calculation. So in gen of a block is the variables used in block before it has been redefined. So let's see what all variables are used in block 6. Here C is used, hence you write C. And kill is variables defined in B. There is no variable that is defined in B, hence kill is empty, null set. Coming to block 5, you have A being used, hence write A in gen, and there is no variable defined here, hence you write null. Okay. Moving on to node 4, gen will be B because B is used, and kill will be A because A is being defined here. Okay. Moving to block 3, both B and C are used here, hence I'll write B, C, and B and C is being defined, hence I'll write C here. Okay. In node 2, A is being used, B is being defined, write AB. And in block 1, there's nothing being used, but A is being defined, hence you write empty in gen and A in kill. So this is the gen and kill set that we'll be using to solve this problem. Now once doing this, you can carry on with the iteration. Okay. So in 0th iteration, you can assume all out and in sets to be iteration 0 to be empty. So you initialize everything to be null, right? Okay. So coming to iteration 1, this is initialization step. Now only we are actually applying the gen and kill and using the out and in formula. So here if you go and look at out of a block is defined as in of S, right? In of S is X, S belongs to successor of B. So when you look at node 6, there are no successors to it, right? And so you can just write null. You can just write null for it. And if you go and look at in of a block, then it is gen of block. So what is gen of B? Gen of B is C, right? So gen of B is C union out of B. Out of B is null minus kill of B. Kill of B is null again. So this just cancels out. You don't have to take anything. Hence you can write C here. Okay. Now what is out of node 5? Again, out of node 5 is in of S, where S belongs to successor of that node 5. You see what are the successors of node 5? You can see one arrow mark is going downwards and one is looping back to 2. So there are 2 successors of node 5, which are node 2 and 6, right? So what you do is you take the in of both node 2 and node 6. So that is the out of node 5. So the in of node 6 is C, in of node 2 is null set, right? So you can just write C here. Okay, now calculate in. So for in of node 5, you take gen of node 5 A union out of B. Out of B you have already calculated, which is C, minus kill of B. Kill of the node is empty, hence you can just ignore. So you just take union of these both and write as A C. Okay, moving on to node 4, we calculate out of node 4. Out of node 4, so there is only one successor for node 4, which is 5. Hence you take the in of node 5. So you write A C here. Now calculate the in of node 4. What is gen of node 4? B, right? B union uh, out of B is AC minus kill of B. Kill of B, which is node 4, is A. Hence you can cancel out A and take the union of B and C, which is BC. Okay, now out of 3 is basically you see the successor of 3, which is 4. Hence you take the in and just write it here. So BC. Now in of 3 is gen of 3, which is BC, minus out of 3, which is BC again, sorry, union BC minus kill of C, sorry, kill of 3, which is C. Hence you strike off C, take union of this, it will be BC. Okay, now you come to 2. You see the successor of 2, which is 3. Hence you take in of 3. In of 3 is BC. Hence you write BC here. Now in of 2. In of 2 is gen of 2. Gen of 2 is A union out of B. Out of B is gen of B is out of you've calculated already, which is BC, minus now kill of node 2, which is B. Hence you cancel out BB, you'll have AC. Again, out of 1 is no successor, so you just take the in of 2 and write here. Now again calculate in of 1, which is gen of 1, which is empty. Gen of B is gen of B is empty, union out is AC minus kill is A. Hence strike out, take the union of these both, which is C. So first iteration has been done. Okay, now you can go ahead and do the iteration next time. So when do we stop the iteration? When the new out in values match the previous out in values, you stop there. Okay, these both doesn't match, hence you carry on with the next iteration. Now you have out in. Okay, now you apply the same formula. So out of node 6 is just again it's empty only because there's no other thing going out. Let me just keep it here. and in is again gen of b, which is what, c union out, right? Out of b is out of b is this one minus kill is empty, hence you just write c. Now you again see the successors of 5, which is 6 and 2, and hence you write the in of both 6 as well as 2. Now you can see in of 6 is c, so c. In of 2 is here. In of 2 is a value. Before it was empty, but now there is a value. Hence you take the union away and c and write ac here. See, there is a change in the previous iteration for in of, out of 5, and now there is a change. So yeah, and again you apply the same formula. In of b is gen a union ac minus kill, hence you just write ac. Now you can just carry forward the ac here over here, because there's only one successor, there's no loop, hence you just write ac. In is again what, gen my union, always right. Okay, so union ac minus kill of a, you kill aa and you write bc. Okay, now you can just write bc here, and now this one is bc union bc minus kill is c, you kill c and you take union, hence it is bc. Now you just take this and write bc here. Again gen is a union bc minus b, you kill b, you write ac. So next is you can write ac here, and so gen is empty, union ac minus a cancels out, hence you write c. This is the second iteration. Okay, when you go to the third iteration, you notice there's only one change here, right? c and ac. Okay, that is because we had a value for in of 2, hence we union with the sixth in, and then we got a different answer. But if you look at this one, it is the same. Okay, hence the next iteration will also be same as the second iteration. So it is better you can calculate and see, but I'll just stop here. Hence it is just same. So anyways, the 5 out of 5 will be ac, and rest all will remain the same. So when you have two iteration which have the same ordinate, as I told you before, you can just stop it. So this is the calculation table for the flow graph. So thank you for watching. Bye.